Hi, and welcome to our next example. This is a method called superposition, and in this example here we have one voltage source and we have one current source. So what we're going to do is examine the circuit using one source at a time. To do that, we're going to open the current sources and short the voltage sources. For this step here, step number one, we are going to open the current source. So on the right hand side, you're going to see this here. We'll have it open on that side, and we have our load resistor in the middle. So we'll just label this here. We have a voltage source that's 18 volts. We have our 6 ohm resistor up top, and we have our load resistor, which is 2 ohms. We have a very simple series circuit. So we can easily find the current moving through the load in this case here. And you can see that the current from the voltage source is going to be traveling in the clockwise direction. And that is important in these types of questions. So to find the current due to the voltage source, V, we'll take 18 volts and we'll divide by the total resistance, which is 8 ohms. And that will give us a current due to the voltage source of 2.25 amps. So that is step number one. And note here that that current is going down through the load resistor. And as I mentioned, that will be important as we look at the other sources in the question. So that's step number one. Step number two, we're going to open the current sources and short the voltage sources. For this step here, we will short the voltage source on the left-hand side. So if I redraw the circuit with the shorted voltage source, it's going to look like this here. And you're going to see that the load resistor stays where it is. That's in the middle. And so this is our circuit here. So it's really just a circuit with a current source. And notice here that we have our two resistors, and they are in fact in parallel. So we have a 4 amp current source, and because those two resistors are in parallel, then some of the current is going to go through the load resistor, and some of the current is going to go through the other resistor, like so. In this case here, the current is flowing up through the load resistor. So let's take a look at this and figure out what is going to be the current going through the load resistor. Well, first we have to note that 6 ohms is in parallel with 2 ohms. So we need to find that because we're going to use the current divider formula. So the total resistance between those two in parallel is equal to 1.5 ohms. So there, we can use that when we plug in to the current divider formula. So let's write that formula out. So the current through the load, if we just focus on the load, is equal to the total current, and that will be multiplied by the total resistance divided by the resistor that we're going through. In this case here, it's the load resistor. So we just need to plug in our values here, and we know all of these values here. We know that I total is equal to 4 amps. That's from the current source. We know the total resistance is equal to 1.5 ohms, and we know the load resistor is 2 ohms. So just plugging these in here, you're going to see that your current that's going to go through the load is 3 amps. And it's important to note here that that current is going from the bottom up. So it's going up through the load resistor. That's going to be important. In the next step, we got to remember which way these currents are going. So that one's going up through the load resistor. Then moving on to the next step, we have to find the algebraic sum of the currents from each source. So the current from the voltage source, if you remember from step number 1, was 2.25 amps. And recall that that was going down through the load resistor. So that's down. And then recall from the last step, the current from the current source was 3 amps, and that was going up through the load resistor. So we need to find the algebraic sum. And we could have used a negative convention here, but we'll just subtract here because we know that they are opposing. So it's going to be 2.25 amps. And if I subtract the other current, then I'm going to get a net current of 0.75 amps. And important to note the direction, that is either a negative, or we'll say that that's 0.75 amps going upwards. So note the direction of the current in the load resistor. In order to get the load voltage, we're going to take that current and multiply by the load resistor. Recall the load resistor is 2 ohms. So multiply by 2 ohms, and we get a voltage drop across the load of 1.5 volts. So that is using superposition.